And the material is posted on Canvas sa discussions. No? Download nyo na lang. Okay. So let's start our discussion. This chapter 5 is about monoprotic and polyprotic acid-base titration. Okay. So this is the chapter outline. So we will try to cover up to this part. Okay. So for our session today, we will discuss the titration overview. Madi-discuss din naman to sa sa lecture. Then we will go with some concepts in the titration calculation process, and then proceed tayo with the monoprotic titration, specifically the strong acid, strong base titration. Then by next meeting, we will discuss this. Okay, we will discuss weak acid, strong base, weak base, strong acid, and acid base titration indicator, and polyprotic acid base titration. And then for Tuesday next week, titration of acid base mixture tayo. Okay, so we are expecting 3 meetings for this session and expect 2 quizzes as well. Diba? Bungad na bungad, dalawang quiz agad, no? So we will have 2 quizzes. Okay, so 20 points each and 2 attempts, no? Yung 2 attempts, makakatulong na yan sa inyo para makabawi talaga, no? And other than that, magpo-provide pa rin ako ng mga worksheet materials with answers, no? To help you with your review, no? And just a short disclaimer, my approach in this topic is very different with the approach of other people on YouTube, no? For example, Khan Academy, si Organic Chemistry Tutor, o kaya si Chemistry Jesus natin, si Professor Dave Explains, no? So, yun. So, ibang-iba yung approach ko sa kanila. Why? Because their approach is, equilibrium talaga. Okay? So, ang kanilang approach sa titration ay equilibrium. However, ako, gusto ko shortcut. Okay? Kaya kung may makikita kayong equation na sa akin na iba sa kanila, magkaiba talaga. Bakit? Kasi yung akin, isi-shortcut natin. Remember yung mga square root of tsaka? Yun yung gagamitin natin. Sa ibang references kasi, for example, textbook, and then yung mga YouTube videos na iba, sa ibang channel, equilibrium talaga. Okay? The problem with equilibrium is it will take you a lot of time to solve for one item only. Kaya isi-shortcut ko. Okay? So yun yung disclaimer ko lang. Baka kasi mamaya magtaka kayo, no? Ala sir, iba dito. Bakit ganito? Hindi mo naturo. Iba kasi yung approach ko. Okay? So my approach is somehow similar to a review class, no? Para siyang nasa review center tayo sa board exam. Okay? Kasi itong mga ituturo ko, ito yung mga nakuha ko sa review center, no? Nung 2018. Nag-take ako ng boards, no? Kaya yan. So, ganun ha. Disclaimer lang. Shortcut gagawin natin. Pero explain ko pa rin bakit naging ganun. Okay? And ang basis pa rin is equilibrium naman. No? Pinadali nga lang. Okay? So, with that disclaimer, we can now proceed to our main dish. No? So, titration. So, titration is a form of volumetric analysis. So, when we say volumetric analysis, we are pertaining to quantifying substances based on their volumes. No? Ibig sabihin, liquids tong mga ginagalaw natin sa titration. Ibig sabihin, pag liquid, may volume. Okay? So, in titration, we react two liquids to completion. Okay? So, for example, you have a liquid of acid, you have a liquid of base. Pagsasamahin mo sila until the reaction is complete. When we say reaction is complete, the moles of the substance are equivalent or equal. Okay? And how will we know if the reaction is complete? No? Titration is often, the completion of titration is often observed using chemical indicators. No? Ibig sabihin, may mga kulay tayong ma-observe pag tapos na yung reaction with the help of chemical indicators. Okay? Say for example, yung acid, clear liquid yon. Yung base, clear liquid yon. For example, liquid sosa, pati muriatic acid, paghaluin mo yon, hindi mo alam kung tapos na yung reaction, di ba? So we need chemical indicators, no? para kumulay. And from the color, we can infer that our reaction is complete. Okay? So yun yung idea natin sa titration. May liquids dito, and we determine their volumes so we can know their quantities. Okay? And the completion of reaction is inferred with the help of the chemical indicators, which produces color. Okay? So this is the typical titration setup. So dalawang glassware ang gagamitin natin primarily. The Buret, the long tube here, and the Erlenmeyer flask. Okay? Itong nasa baba. Bakit hindi beaker ang gamit? Kasi i-swirl natin kasi itong Erlenmeyer, no? Ini-swirl yan, no? Iniikot-ikot, no? Ang problem with beaker is that since malaki yung opening niya, tatalsik yung liquid, no? Pag in-swirl mo yun. Kaya we use Erlenmeyer flask para confine ang liquid, na hindi siya mag-spatter out, na hindi siya tatalsik. Okay. So yan. So on the Buret, we have the liquid here called the Titrant, no? Andito yung Titrant. And nasa Erlenmeyer flask ang Analyte. Okay? So mamaya define natin yung Titrant and Analyte, ha? And the Titrant and Analytes are combined to complete the reaction. With the help of the indicator, malalaman natin that the reaction is complete. Okay? In your lecture, you will find out that there are many types of titration. No? So sa lecture ko, ang dami ng titration na nilagay ko ay 4. So merong neutralization titration, merong complexometric, merong precipitation titration, and then we have the redox titration. But for simplicity, since tayo, medtech student, di naman tayo BS Chem, no? So, ang aaralin lang natin is the neutralization titration. Okay? So, this is our primary focus on this chapter. When I say neutralization titration, what do we know about neutralization? Ibig sabihin nun, you are reacting acids with bases, no? Acid plus base, tawag doon, neutralization reaction. Okay? Kaya neutralization titration tawag doon. Okay? So we use this to determine the concentration of acids or bases, no, in our daily products, no. For example, sa detergent, gusto mo malaman how much sodium carbonate yung nandun. Titration gagawin mo. Kunwari, liquid detergent, gusto mo malaman how much sodium carbonate andun. Neutralization titration din ginagamit doon. Okay? So, yan. Okay? So, yan lang yung idea. Titration is a volumetric analysis. Okay? Ibig sabihin, may mga tubig. Dalawa yung uri ng tubig natin. We have the titrant liquid and the analyte liquid. No? Okay? We react the two to completion, and the completion is inferred by the color of the chemical indicator. Okay? The primary focus is neutralization, titration, or acid-base reactions. Okay? So, paano ba ginagawa ang titration process? Okay? So, remember, you have your Buret, and somewhere down the Buret, meron tayong tinatawag na stopcock or valve. No? Ito yung stopcock or valve. No? Yun talaga tawag sa kanya. So, ito yon. So, ginagawa dyan, you twist it, so that the liquid from the Buret will be transferred down to the Erlenmeyer flask. So we add the liquid from the Buret to the Erlenmeyer flask sequentially. Ibig sabihin, unti-unti lang until a color change can be observed. No? Until may makita tayong pagbabago sa kulay. For example, this is an acid-base titration. So ang gamit namin indicator ay phenolphthalein. Didiscuss natin yun na maigi next meeting. Okay? So, when the reaction is complete for a neutralization reaction, magkukulay pink siya. Okay? Kaya nga nakaka-enjoy itong titration. No? Sayang hindi nyo ma-experience ngayon. Pero hopefully, ma-experience natin someday after the pandemic. No? Kasi colorful siya. No? Magdagdag ka nito, patak-patak, until suddenly, kulay pink na siya. Tapos gagawin nyo na yung picture sa inyong IG. May nakapag-try na pala mag-titrate na si Rowan at Diane. Okay. So yan, masaya to, 'di ba? Pero ano, medyo effort din. So, patak-patak lang until biglang mag-pink yan. Okay? So, ano yung pinapatak natin? Remember that the liquid in the buret is called the titrant. Okay? And saan yun nilalagay yung titrant? Sa analyte. Yun yung nasa baba. Okay? And again, incremental ang addition ng titrant. Patak-patak lang. No? Kasi dahan-dahan lang dapat. No? Kasi pag lumagpas ka dyan, then we will call it over-titrated. Okay? So, yun. So, mamaya, discuss natin yung in details. Let's have an overview of some jargons we use. So, jargons, ito yung mga technical terms na gagamitin natin sa chapter na to. So, these are some defined terms. So, when you say analyte, you already know analyte. Nasa chapter 2 natin to. Analytes are substances with unknown concentration. Ibig sabihin, hindi mo alam kung ano yung kanyang concentration or yung dami or yung kanyang identity. Ang question doon is, paano mo malalaman kung gaano karami yung analyte? We react it with the titrant. Okay? We react the analytes with the titrant. Okay? So yung titrant or standard, no? Familiar na dapat kayo sa definition ng standard na sa chapter 2 to. So sabi natin doon, standard or titrants are substances with known concentration. Okay. Ang logic sa titration ay ganito. Hindi mo alam kung gaano karami yung analyte. Okay? Alam mo kung ano yung concentration ng titrant. Ibig sabihin nun, if I react certain moles of the titrant, no? Pag nag-react ako ng ilang moles ng titrant sa analyte, then using stoichiometry, pwede ko malaman yung concentration nito or yung kanyang molecular formula or the molar mass. Okay? So, yun yung logic sa titration. Hindi mo alam kung ano ito or gaano to karami. Pero, you know that this will react with the titrant. So, using stoichiometry, by identifying how much titrant is used to react with the analyte, pwede mo malaman kung gaano to karami or pwede mo malaman yung kanyang molar mass. Okay? So, yun yung logic ng titration. Aalamin mo yung nawawala sa tulong ng titrant. Okay? Sa tulong ng dami ng titrant na nag-react with the analyte. Okay? And again, the reaction is aided, no, with indicator, no? Kailangan ng indicator para malaman mo kung tapos ka na, no? Kasi mamaya, ito nangyari sa amin to last year, no? Before the pandemic, nagta-titration kami ng students ko. May student ako, patak siya ng patak ng buret until naubos na. Yung pala, hindi niya nilagyan ng indicator. So, hindi niya alam na lagpas na siya, no? Or tapos na yung reaction. So, yun. Kailangan lagyan mo ng indicator. Because again, our analytes and titrants are commonly colorless sila. Colorless yan madalas. So, for you to be aware kung tapos ka na, you need an indicator. So, what is an indicator? Indicators are organic molecules. Organic molecule yan, in which, depending on the pH of the solution, magbabago siya ng color. Okay? So, you may be familiar with the red cabbage, no? Ginagawa to nung high school eh. Pinakita to sa amin ng teacher ko ng chemistry nung high school kami. So, we have a red cabbage, pinakuluan namin, and then the extract of the red cabbage was used to determine the pH of the solutions, no? Pag nilagay mo yung katas ng red cabbage sa suka, iba yung kulay niya compared sa kulay niya with, let's say, Kremil S o kaya liquid Sbsa. Okay? Okay. So, ganun yung concept ng indicators. Now, these are organic molecules that respond to pH changes. No? And depending on what pH yung solution, may corresponding color doon. Okay? Makikita natin next meeting yung mga iba't ibang uri ng indicators. Okay? So, yun lang yung idea. For acid-base titration, the commonly used indicator is the phenolphthalein indicator, which has a distinct pink color when the reaction is complete. No? Kulay pink siya pag tapos na yung reaction. Okay? So, yun yung indicator. And the next one, we have the equivalence point and the end point. No? So the equivalence point, from the word itself, equivalence, ano yung root word nito? Equal. Okay? So this is a point where the analyte mole is equal to the titrant's mole. Ano? Ibig sabihin, the mole of analyte is equal to the mole of titrant at equivalence point. And ano meaning nun? Kapag equal na sila, the reaction is complete. Okay? So equivalence point is the point at which the moles of the titrant is equal to the moles of the analyte, meaning the reaction is complete. Ibig sabihin, tapos na yung reaction. Okay? Pag may equivalence point. Okay? Ang tanong is, paano ko malalaman yung equivalence point? No? With the help of the endpoint. Okay? The endpoint is the estimate of the equivalence point. Okay? So ito yung endpoint, ito yung ma-observe natin sa experiment. And the endpoint is an estimate of equivalence point. No? Estimate lang. Kasi measurement to eh. Remember, pag nagme-measure tayo, we are just actually estimating stuff. No? Okay. So, ang endpoint, this is measurable sa experiment. And it tells us about the estimate value for the equivalence point. Okay. So, kailan mo malalaman kung endpoint na or equivalence point na kapag kumulay na yung indicator. Okay? May desired color para malaman mo na tapos ka na. For acid-base titration, the desired color is the faint pink color. Okay? So, yun lang yung idea. Okay? So, for us to visualize this, sayang kasi wala tayo sa laboratory. Maganda sana to i-demonstrate sa inyo. No? And gustuin ko man mag-demonstrate sa bahay, okay lang naman kasi may license ako. Okay. Ang problem is mahal yung gamit, no? So, for example, ang Buret, that's 1,500 agad, no? Chemicals not included pa. So, medyo mahirap mag-demo sa bahay. Okay. So, dahil doon, we will watch a short video clip na lang on the titration process, no? Overview lang to, and then I will share some insights about the video. Okay? So, nood muna tayo. This is from Carolina University sa Carolina. Hindi ko alam kung UC Berkeley to. Pero anyway, panoorin na lang muna natin to.
I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today, we will be discussing the proper titration technique using the complete single Buret assembly kit available from Carolina Biological Supply Company. This is the first in a two-part video series on titration. The purpose of a titration is to quantitatively determine the concentration of an unknown solution, commonly called the titrand or analyte, by adding a volume of a chemical with a known concentration called the titrant. To mark the endpoint of a titration, an indicator is added to the analyte. Let's review some of the equipment that's needed for a titration. Carolina's complete Buret assembly contains the basic equipment to get you started, including a Buret, ring stand, and a Buret clamp. A Buret is a long, narrow, graduated tube used to add titrant. It has a stopcock to regulate the flow of liquid. Notice that the markings on the Buret go from lowest at the top to highest at the bottom. The ring stand and Buret clamp are used to mount and secure your Buret. Other materials you will also need include a small funnel to help you fill the Buret, a 125 milliliter Erlenmeyer flask, which works best for titrations. The shape of the flask allows for more vigorous swirling than a beaker or other glassware and minimizes spill hazards. A volumetric pipette and pipette bulb to transfer a known volume of analyte to the flask. A wash bottle filled with deionized water, a beaker or flask of titrant and of analyte, indicator selected for your reaction, a reading card to help read the meniscus, and a sheet of white paper to help visualize the endpoint. To prepare your Buret for the titration, it is good laboratory practice to rinse your Buret thoroughly with deionized water, then with a small amount of titrant. After each rinse, open the stopcock to allow the liquid to drain out the bottom. If there is a lot of liquid clinging to the walls of the Buret, Then thoroughly clean your burette and repeat the rinse process. The accuracy of this technique is dependent on the titrant flowing into the flask and not sticking to the walls of the burette. Mount the burette in the clamp, making sure it is positioned vertically, and there is enough room to position your flask underneath the tip. Check to see that the stopcock is in the closed position. Insert the funnel into the top of the burette and fill with titrant almost to the top. Filling exactly to the 0 mark is not necessary, but you do need sufficient titrant to complete the reaction. Check the column for air bubbles and gently tap to free them from the side walls. Remove the funnel. Place the Erlenmeyer flask under the tip and open the stopcock to allow a few milliliters of titrant to flow through, releasing any trapped air. Rinse the tip of the burette with water. Empty the liquid into a waste container and thoroughly rinse the flask. It is not necessary to dry the flask. Record your starting volume. It is important to accurately read the volume on the burette. First, note that the liquid forms a concave meniscus because the water pulls itself up the side walls of the glass. You should read the volume from the bottom of the meniscus at eye level. Secondly, it is important to read your volume to the correct number of significant figures. This burette indicates volume to the nearest 0.1 milliliters. With any graduated glassware, record the volume to one additional decimal place beyond the smallest graduation. In this case, record the volume to the nearest hundredth of a milliliter, estimating the final place. Use the volumetric pipette to transfer the analyte to the flask. Add a few drops of indicator to the flask and swirl. Place the flask under the tip of the burette. Record this volume. Placing a piece of white paper under the Erlenmeyer flask may make it easier to detect the color change. Operating the burette requires 2 hands. One hand turns the stopcock, while the other hand swirls the flask. Practice turning the stopcock a few times to familiarize yourself with how quickly the flow starts and stops. It is common laboratory practice that the first titration is an estimate. Open up the stopcock and allow the titrant to enter the flask quickly. Continuously swirl the flask. As the volume of titrant in the flask increases, the color of the indicator appears, then disappears as you swirl. When the analyte becomes a colored solution, close the stopcock. Record the final volume of the burette. Subtract the initial volume from this final volume to get the estimated volume of titrant needed for this titration. Knowing the volume that is a little past the endpoint, subtract 5 milliliters from that number to get the amount of titrant that can be safely added before a slower addition is required. As the estimate titration shows, a dark-colored solution indicates an excess of titrant has been added. The desired endpoint is a pale, faintly colored analyte. To reduce the risk of passing the endpoint, slow down the addition of titrant when flashes of color begin to appear in the analyte. Adjust the stopcock to slow the flow of titrant to a dropwise rate. Continue to swirl the flask with one hand and keep the other hand ready to close the stopcock. When you notice the indicator taking longer to fade, close the stopcock. Rinse the tip of the burette with deionized water and swirl the flask. Record the final volume on the burette. If the analyte remains faintly colored, then you have reached the endpoint. If the analyte is still colorless, then repeat these steps. Add a drop, rinse, swirl, and record until a faint color persists. Typically, titrations are performed in triplicate. Use the average volume of the titrant required to reach the endpoint for any calculations. You now know how to properly perform a titration. Be sure to check out the second video.
Okay. So anyway, ano nangyari sa video? So the video just showed us kung ano yung ginagawa sa titration. Okay. So in this portion of the video, ito. So dito sa portion na to, ito yung excess, 'di ba? This is the excess titrant added to the analyte, no? So it is very pink, no? Pink talaga yung color kapag sobra ka na. But the desired color is this one, faintly pink. Kaya important na may paper sa ilalim. So yun, so we will wait until this faint color is observed, no? So yan, patak-patak lang until suddenly maging pink siya. Ganito lang yung pink, hindi ganito, ha? Okay, so yan. And so yan, we will wait until this color appears, no? So when that color appears, no, hindi na siya nawawala, then that means the reaction is complete, no? Okay. So pag consistent na yung color na ganyan, kasi 'di ba may portion din yung video kanina na pinakita niya, itong part 'yon, yung hinahalo niya tapos biglang nagfe-fade, no? Yun yung reason ba't kailangan mo i-swirl kasi on this portion of the liquid, tapos yung reaction on the other, hindi, no? So to evenly distribute the molecules, uh, you have to agitate the container, no? Yan ang galaw-galawin mo yung container para ma-distribute yung liquids evenly. Okay? And once the molecules are enough, no, to react with there is an enough number of molecules to react with the analyte, doon na mag-start siya magkulay pink na light. Okay? Light pink lang yung desired natin. Okay? So that's the titration process, no? Sayang kasi hindi natin siya magagawa kasi we are at home. Pero I hope na makita natin yung idea lang na ganun yung titration. So, gagawin niya ba to sa field ng medtech? I think hindi. No? So, hindi niya siya gagawin sa medtech. No? Ibang type of analysis yung ginagawa niya. Usually, spectrophotometric. No? Didiscuss din natin yun in the future. Okay? Pero yun. So, sayang lang kasi wala tayo sa lab. Okay? But anyway, so that's the concept of the titration process. No? You have your titrant, you react it with analyte, and then, yun. When the reaction is complete, a color will be observed now. Faint pink color in this case. No? So, yan. So, ngayon, let's talk about the technicalities ng titration. No? Other than the fancy colors, syempre, hindi masaya yung chemistry kapag walang calculation, di ba? So, calculation tayo. So, so after you do the experiment, no, so you have to take note of this para malaman mo kung ano yung mga calculations necessary to carry out the process, no. Okay. So sa titration calculation, it will be easier if you know the following, okay? Mas madali mag-titrate at mas madali mag-compute sa titration basta alam mo ang mga sumusunod na pointers, okay? So what are the pointers I listed here? Number 1, take note that when you have a weak acid and a conjugate base, or a weak base and a conjugate acid in your solution, you are in the buffer region. Okay? Kunwari, pinag-titrate ko kayo ng acetic acid, ng suka. So alam mo na pwede mag-exist yung buffer region kapag nadagdagan ang conjugate base, no? So, yan. So, in the presence of acid conjugate base or base conjugate acid pairs, no? In the presence of these pairs, we can use the Henderson-Hasselbach equation because we are in the buffer region. Okay, so if you want to compute the pH of the solution in a buffer region, use the Henderson-Hasselbach equation. Naalala pa ba? That's pH equals pKa plus log conjugate base over acid. Kung base naman yung meron ka, that's POH equals pKb plus log conjugate acid divided by the base. So that's the Henderson-Hasselbach equation. Take note also, when you add acid sa base, nababawasan yung base. And when you add base sa acid, nababawasan yung acid. Bakit? Bakit ganon? Kasi, di ba, we are reacting to species, no? Ibig sabihin, when you react to species, nababawasan yung original. Okay? So, suppose yung acid ko, lalagyan ko ng base, patak-patak. Ibig sabihin nun, sa Erlenmeyer flask, nababawasan yung acid ko. Okay? So, kunwari naman, yung base ko yung nasa Erlenmeyer flask, no? Tapos nagpapatak ako ng acid sa Buret, patak-patak lang. Ano nangyari sa concentration ng base sa Erlenmeyer flask? Mababawasan din. Why? Because acids and base react Nagre-react sila, kaya nababawasan sila over time. Okay, so you have to take note of that. And then also, since dalawang liquids yung pinag-uusapan dito, when you combine liquids, what happens is that yung kanilang concentrations ay nagbabago because of the dilution, and you have to account for that. Okay? You have to account for the dilution process. Ang daming nangyayari, no? Akala nyo patak-patak lang siya. No, ang daming nangyayari. You have to take note of the changes in the concentration. You have to take note of the dilution process. Okay? Pero as long as you know the equations here, madali na lang. Okay? And of course, knowledge of equilibrium will be very helpful. No? Okay, so nilista ko na dito yung mga common equations that we will use, although mas marami pa akong ipapakitang equation later. Okay, so ito yung mga conceptual equation na kailangan natin dito. Stoichiometry calculations, mole titrant equals mole analyte. This is the equation to be used when we are at the end point. Okay, pag nasa end point tayo, we say that the mole of titrant is equal to the mole of analyte. Endpoint or equivalence point. Kaya nga equivalence equal. Okay, equal yung moles nila. Okay, so equal yung mole ng acid, equal yung mole ng base. So equivalence point yon, or at the end point. So we know that the moles can be expressed as molarity times the volume. Okay, remember that. So molarity, di ba, is mole over volume. Rearranging the equation, we will get mole equals molarity times the volume. Also, we can express molarity, we can express mole as the ratio of mass and the molar mass. Pwede rin yun. Okay? So ito yung mga equations natin for the mole. Remember that, no? Hindi pwedeng nakalimutan nyo yan kasi important to sa buhay chemist, no? Buhay ng isang chemistry student, important to. Okay? So yan. So you know how to express the moles of a titrant and the analyte in terms of the mass or the volume. Okay? Ayan. Anyway. So yun. Suppose ito, dalawang liquid to, di ba? Sabihin natin dalawang liquid sila. So we will use the N equals M times B. Okay? Kasi liquids eh. So molarity times the volume. So the mole of titrant can be written as the molarity titrant, volume titrant times SFT. Ano to? Stoichiometric factor or the coefficient. Okay? So, kunwari sa isang balance reaction, may 2 yung coefficient na yun. Ilagay mo dyan 2 times this. Okay? Or times 2 ito. Kunwari, 1 lang coefficient niya, edi burahin mo na lang yan. Okay? So, the stoichiometric factor has to be accounted here. Okay? Kailangan isama mo siya doon. Okay? So, ganun din sa analyte. Liquid yung analyte kunwari. So, the liquids can be expressed as molarity times the volume. Okay, so that's MAVA times the stoichiometric factor for the analyte. Saan makikita yung stoichiometric factor? Sa equation, sa chemical equation. So, by now, you should know how to write chemical equations, especially for acids and bases. Okay? So kung gusto niyo ma-review doon, I will upload my lecture video on chapter 5. Natapos ko na 'yon sa classes ko, in chapter 5, no? Kanina lang umaga. Kaya kung gusto niyo rin panoorin 'yon, feel free to watch, no? So 'yan, para ma-review kayo slightly on the balancing ng equation and basic stoic calculation. Okay? So 'yan. After that, ito pa yung isang equation na important, dilution calculation, because again, when you add two volumes, the volume increases, hence the concentration decreases. So you have to use this formula, M1V1 equals M2V2 or MIVI equals MFVF. Now, next one is the equilibrium calculation. This is very important, especially when we have weak acids and weak bases in our system. Okay. So remember that Ka times Kb is equals to Kw or 1 times 10 raised to negative 14. Okay? Or the concentration of H times the concentration of OH equals Kw. Remember that, huh? And also, we will find this equation very useful. The square root of Chaka and the base form nun. The square root of CbKb. Okay? So, itong dalawang equation, itong tatlong equations na to, we will find this relevant sa ating topic, no? And then lastly, buffer calculation. Again, kapag may equilibrium ka, matic, pwede mo gamitan ng buffer equations, no? Provided that there is a conjugate base acid pair, no? Okay, so yan, this is the Henderson Hasselbach equation for the pH. If you want the POH version, palitan mo lang yung H ng OH. Yung Ka, palitan mo ng Kb. Ay, wait lang. Plus logarithm ng conjugate base divided by the acid. Okay? So, yan yung base form niya. So, lahat ng equation na to, alam na natin to kasi na-discuss na natin to since first semester. So, ngayon, it's up for us to apply all these concepts na lang. Okay? So, mukha bang mahirap yung topic na to? Slight lang. Okay, slight lang. Sa una lang siya mahirap, pero once na nagso-solve na tayo, makikita mo na yung yung connection ng equations, no. Okay? So mas ma-appreciate niyo na yung equations, no? Sa una lang siya parang ay ang daming nangyayari. Marami kasi talaga, no. Pero kaya 'yan, okay. Okay, so kaya 'yan, guys. Okay. So now, let's proceed with the first type of acid-base titration. Start na tayo agad sa calculation. Agad-agad. We have the monoprotic acid-base titration. The monoprotic acid-base titration or monoprotic titration refers to a condition wherein your analyte and your titrant ratio is 1 to 1. Okay? Ibig sabihin nun, yung acid and yung base, ang ratio nila ay 1 and 1. Bigay tayo ibang examples nun. Bigay tayo ibang examples. Sodium hydroxide plus HCl. 1 to 1 yan. Yung sodium hydroxide, isang OH ibibigay. Yung HCl, isang H ibibigay. Okay? So, 1 to 1 yan. Monoprotic yan. Ano pa ibang example? Acetic acid, HAC plus, let's say, potassium hydroxide. Okay? So, yan. 1 to 1 ratio niyan. Yung suka natin, isang hydrogen ibibigay niyan. Ang ating potassium hydroxide, isa lang din ang ibibigay niya. Okay? So, that is the monoprotic acid-base titration. When your acids and your bases react with 1 protons lang na. 1 proton lang na. Isa lang yung proton na pinagpapasapasahan nila. Okay? So, yan. So, ibig sabihin nun, we can reduce this equation as, we can reduce this to MTVT equals MAVA. Okay? Kasi 1 to 1 lang yung stoic factor natin. So, we can reduce this equation into this. Important yan, ha? Okay, so let's proceed. Okay, so monoprotic acid-base titration is composed of 3 different subcategories. We have the strong acid, strong base titration, and the vice versa non. Strong base, strong acid titration. We have the weak acid, strong base, the weak base, and the strong acid titration. Okay, so ano yung difference nito? Ang equation ba na gagamitin ko dito ay same dito? No. Bakit? Kasi ito. Ang difference ng strong acid, strong base titration is that it follows the stoichiometry. It follows basic stoic and dilution equations. And that is very different with weak acids and weak bases. Why? Because they follow equilibrium equations. So, ibig sabihin nun, depending on our situation, may equation na dapat gamitin. Okay? So, iba-iba yung equations na may encounter natin dito. Okay? Kaya, yun yung disclaimer ko. Ang daming equations dito. Pero, nilista ko na yun. Okay? Nilista ko na yan. For example, ito. Nilista ko na lahat ng equation na gagamitin. Ano lang kailangan mo gawin? You must identify kung anong type ng titration ginagawa mo. Is that a strong acid, strong base? Weak acid, strong base? Weak base, strong acid? Identify mo yon kung asan ka dyan. And once you were able to identify what type of titration you are doing, then you should apply the necessary equations. No? Okay? So, yun. Yun yung important ha. Okay? So, mukhang mahirap itong topic na to, pero kakayanin. Ano lang una mong gagawin? Alamin mo kung anong type of reaction ginagawa mo. Kung strong acids, strong base ba yan, or may weak acids or weak bases. Okay? So, yun yung gagawin natin. So, let's proceed with the first one. Okay? By the way, there is a shorthand notation dito. Makikita nyo, SASB nilalagay ko. Strong acid, strong base. Kapag weak acid, WA. Pag weak base, WB. Okay? So, may shorthand notation kami dyan, SASB, WA, WB. So, be familiar na lang. Strong acid, strong base, weak acid, weak base. Okay? So, ganito. For example, we have SASB. That means yung nauna ay yung Analyte. Okay? And yung nasa dulo, yung Titrant. Okay? So, kapag sinabi ko SASB, yung SA, yun yung Analyte. Yung SB, yun yung Titrant. Okay? Kung sino mauna, siya yung Analyte. Okay? So, yan. Punta na tayo dito. So we say that monoprotic SASB titration refers to titration whose strong acids are analytes, no? SA ang analyte. And the titrants ay yung strong bases. Okay? And the titration process is composed of 4 stages. And for each stages, you have a corresponding equation to be used to calculate for the pH of the solution. Okay? So kada stage ng titration may equation to get the pH. Okay? So in titration processes, commonly may 4 na stages. We have the initial, the pre-equivalence, the equivalence, and the post-equivalence point. Okay? So may 4 na stages parate madalas sa titration. Okay? Initial, pre-equivalence, equivalence, and the post-equivalence. Okay? So in order for us to understand bakit ganito yung equation, we should know first what are the species present in our solution. Okay? Para malaman mo, bakit naging ganun yan, sir? Alamin mo muna, what are the species that contribute to the pH? No? Punta tayo sa Erlenmeyer flask. Tingin tayo. Ano yung meron sa Erlenmeyer flask? Yung analyte. And what is our analyte? The strong acid. So that means, initially, wala pa akong nilalagay na titrant. So ibig sabihin, initial yon. So initially, our Erlenmeyer flask contains water and the strong acid, HA. Okay? Yung A, ano na yon? Yung ano na lang niya, anion. Okay? So, yan. Strong acid to. Initial, wala ka pa nilalagay na titrant. You have water and strong acid HA lang. How do you compute for the pH of that? Okay? Paano mo kinukuha yung pH niyan? Okay, remember that for strong acids, the pH can be calculated as kung ano yung concentration niya. I-negative log mo lang yan. Okay? So kung ano yung concentration ng H+, kung ano yung concentration ng strong acid, i-negative mo lang yon, may pH ka na. Ginawa na ba natin yan dati? Ginawa na natin yan. Okay? Doon sa strong acid, sa equilibrium. Okay? Naalala nyo pa ba? What is the pH of this solution? Negative log mo lang yung concentration. Okay? So, ganun. Again, kapag strong acid, initial pH can be calculated directly using the concentration of the acid itself. Okay? So, yun yung dahilan bakit yung equation for H plus ay ito. Equal siya sa concentration of the HA. I-negative log mo lang, you have the pH. Then, what's next? Pre-equivalence. Ibig sabihin nito, pag nag-pre-equivalence na tayo, nagpapatak-patak na tayo ng titrant. Okay? So, isang patak na, patak-patak over time. What happens when I add titrant, no? Unti-unting titrant sa solution? Ano nangyayari? Nababawasan yung acid ko. Kaya sinulat ko dito, HA less. Nababawasan kasi siya. Why? The acid reacts with the base to form the salt. Okay? So, ibig sabihin nun, nadadagdagan yung salt, nababawasan yung acid. Okay? So, ito yung mga species present in our Erlenmeyer flask. We have the water, syempre, as the universal solvent. We have the HA na nabawasan kasi nag-react siya with the base, and the salt produced by the neutralization reaction. Okay? So, since nabawasan na yung acid ko, so for me to get the concentration of the acid sa solution, I will use this formula. O, ano ganap na ito, sir? Bakit naging ganyan yan? Okay. So for me to determine how much acid is left, okay, paano mo malalaman how much acid is left? You can simply subtract the moles of acid minus the mole of the base added. Okay? Pag subtract mo lang, mole acid minus mole base, makuha mo kung gaano karami natira. Di ba? Okay? So, ganun lang. Mole acid minus the mole of the base added. No? Kung gaano karami yung base na titrant na dadagdag mo, isusubtract mo doon. Pero since kailangan natin is molarity to get the pH, you divide it by the total volume. Okay? Malapit na yung equation natin dito. What is our mole acid? Remember, acid is the analyte. Paano kinukuha yung moles ng analyte? MAVA. Kaya ganyan yung equation. Yung base, ano yun? Yun yung titrant ko. So, MTVT. Okay? So, yun yung reason why the equation is this. No? Kasi nababawasan yung acid. So, to measure how much is left, we use this formula. Mole acid minus mole base kasi nabawasan na yung acid. Divide mo yan sa volume kasi kailangan ay molarity to get the pH. So, kaya naging ganito yung equation natin. Okay? So, ito yung sinasabi ko kanina na kapag nagdagdag ka ng base sa acid, mababawasan yung acid. Ito yon, N acid minus N base. Okay? Asan yung dilution formula dito? Ito yung dilution, yung divide by V total. Okay? Divide mo siya by V total. So, yan. Okay. So, hopefully, na-clarify ko bakit naging ganun yung equation. Again, bakit? Kasi, nabawasan yung acid ko. So, to measure how much is left, N acid minus N base divided by the total volume. Ito yon. Acid is the analyte, MAVA. Base is the titrant, MTVT. Substitute lang, we get this. Diba? Next one. Pagdating sa equivalence point, ano nangyayari dito? Sabi ko sa inyo, equivalence point, this is a point where equal na yung moles ng analyte and the titrant, equal na. So, ibig sabihin nun, may acid pa ba tayong natira? May base pa ba tayong natira? Wala na. Bakit? Kasi lahat sila na-convert into salt. Equal na eh. 'Di ba? Remember, yung equation natin, HCl plus NaO, magiging ano yon, NaCl plus water. So, wala na to. Wala na. Lahat sila na-convert into salt and water. Kaya nilagay ko doon H2O and salt. Of the two chemical species, which of them will give the pH value? Ang sagot doon, the pH value can be obtained from the auto-ionization of water. Okay? Yung water ang magbibigay ng pH value. And what is the pH of water in neutral solutions? The pH of water in neutral solution is 7 automatically. Okay? Automatic 7 yun. Bakit naging 7? Kasi remember, during our equilibrium calculations, when the moles of acids and the moles of base are equal, then we write H plus OH minus equal KW. Since parehas sila, we say h plus square equals kW. Kunin mo square root niyan, we get this. And what is the value of h plus kapag equal yung acids and bases? 1 times 10 raised to negative 7. Negative log mo yon, you will get pH equal 7. So that means for SASB titration at equivalence point, the pH is always 7. Okay? At 25 degrees Celsius. Bakit ko in-emphasize yung 25 degrees Celsius? Kasi remember, the KW changes at different temperatures. Pero for simplicity, we don't care about that. No. Pero dapat alam natin na nagbabago yung KW at different temperature. Okay? Pero again, it is safe to say that the equivalence pH is 7 for SASB titration. Okay? So yan. And then lastly, we are at the post-equivalence point. Anong meaning ng post-equivalence point? Ako na rin, nakalimutan mo patayin yung pinatay talaga yung yung Buret. Nakalimutan mo isara yung Buret. Di patak ng patak yan. Ano mangyayari? Lalagpas ka na sa equivalence point. You will reach the post-equivalence point. Lalagpas ka na eh. Hindi mo enough eh. Okay? So, post-equivalence point yan. So, ano yung magko-contribute sa pH ng solution? Okay, so ito yung mga species present in our Erlen Mayer flask. You have the water, you have the salt, nakalimutan ko i-type, and you have the excess base. Okay? So, sino sa tatlo yung magko-contribute sa pH? Of course, yung excess base. Okay? Ito na yung reason kung bakit may pH reading na tayo kapag sumobra na ng titrant, yung excess base. So, paano mo makuha yung pH? Alamin mo kung gaano karaming OH ang sobra. Gaano ka-excess yung base. And to measure how much base ang sumobra, we use this formula. Paano to nakuha, sir? Okay? To determine how much base is in excess, we use N base minus N acid divided by V total. Sobra na yung base eh. Okay? Kaya para malaman mo gaano ka sobra yung base, i-subtract mo kung gaano karami yung moles ng acid yung nagamit na. Okay? So mole base minus mole acid. Okay? Mapapansin nyo, baliktad siya dito sa pre-equivalence, di ba? Kasi tignan nyo, ano yung sobra sa pre-equivalence? Yung acid. Kaya N acid N acid minus N base, di ba? Acid kasi yung sobra dito. Pero sa post-equivalence, ano yung sobra? Yung base. Kaya pinagbaliktad natin yung equation. Okay? Kung sino yung sobra, siya yung mauuna. Okay? So, ganun. And then we know that base is the titrant. So, we write it as MTVT. And we know that acid is the analyte. So, we write it as MAVA. So, that's why we arrive with this equation. The concentration of OH is MTVT minus MAVA, all divided by the V total. Okay? So, yan yung reason kung bakit natin nakuha itong different equation for the different stages sa titration. Okay? Sa ngayon, siguro may question mark pa. Paano ko gagamitin yan? Mamaya makikita nyo how these equations will be used. No? Okay? So, basta yan lang yung dahilan bakit naging ganyan equation. Okay? So, again, you can, kunwari wala to, you can still determine, kung paano mo makukuha yung correct equation. Basta alam mo yung reaction. Alam mo, initially, yung acid lang yung nagko-contribute sa pH. So, negative mo, log mo lang concentration niya. Pag nadadagdagan ka ng titrant, ibig sabihin, nababawasan acid mo. So, determine how much acid is left. So, use this formula. Then at equivalence point, equal na yung acid, equal na yung base. So, that means the pH is primarily due to water lang. So, 7 yun, matic. Diba? And then, lastly, pag lumagpas ka na, yung excess base mo na yun dahilan, bakit ka may pH reading? So, ito yung equation dun. So, with those equations, yan. Pwede mo na magamit yun sa problem solving. Okay? So, yun. So, itong PowerPoint na to, gumawa talaga ako ng slide with equations for you to save them. Pwede nyo yan i-print, pwede nyo i-screenshot yan, i-share sa friends nyo. Okay? Gawin yung wallpaper, okay lang. Na. Basta nilagay ko na lahat ng equations na gagamitin nandyan. The only, the only task for you to do is to identify asan ka dito. Asan ka sa stages na to. Okay? Mamaya may example tayo doon. Okay? Alamin natin anong stage na ako and I will use the corresponding equation. Okay? So, by the way, if you graph the pH of the solution with the volume of titrant, ito yung itsura niya. If you graph the pH and the volume of the titrant, the graph will look like this. Okay? So, para siyang letter S, no? So, ito yung graph natin. So, pakita ko sa inyo yung mga distinct part dito. Ang initial pH, ayun yung kapag 0 yung x-axis mo. Okay? Siyempre, wala kang titrant na dinadagdag. So, yun yung initial pH. Okay? And then, when you add your titrant slowly, again, based on titrant, what will happen is that the pH will slightly increase. There will be a slight increase in the pH. Dahan-dahan yan. Until biglang stonks, no? Mag-stonks siya. Nakita niyo yung pH mababa, then suddenly stonks, no? Biglang ando na siya. Okay, ano tawag dito sa part na to wherein there is a sudden change in the slope of the curve? Biglang geometry tayo dito. So, ang tawag dito sa part na to wherein we have a big change sa slope, we call that the inflection point. Okay, so ang tawag sa region na to ay inflection point, no? This portion. Okay, inflection points in algebra, or geometry, they are characterized by a steep slope, no? Ibig sabihin malaki yung change sa slope. Okay? So sa inflection point sa chemistry, dun mo makikita yung equivalence point. Okay? So yun yung relationship niya sa chem ng algebra. Again, sa inflection point, dun mo makikita yung equivalence point, no? Okay, so related sila. Pag may nakita kang stonks na curve, okay, so ito yung stonks, biglang umakyat, ibig sabihin nun, andoon yung equivalence point. And andito rin yung endpoint, no? Okay, so somewhere here yung endpoint. Okay, so again, endpoint is the estimate of the position of equivalence point, no? Okay, so yan. So yan, okay, so bali ano uli nangyari? You have your initial pH, dagdag ka titrant, unti-unti aakyat na, then suddenly inflection point, no? In this inflection point, andito yung endpoint and the equivalence point, no? Dito sila makikita. Mapapansin nyo, small change lang yan sa x pero ang laki ng change sa pH. Okay? So yan. And then after the equivalence point, lagpas ka na sa titration, ayun, mataas na yung pH. Bakit mataas yung pH? Kasi sobra ka na ng base, no? Sobra ka na ng strong base. Kaya mataas yung pH. Ayan. Nag-agree yung pusa ko. Okay? So, yan. So, yan yung ating curve. Okay? So, yan. Again, there are 4 stages in the SASB titration: initial, pre-equivalence, equivalence, and the post-equivalence. The unique characteristic of this curve is that we have an inflection point. In the inflection point, there is a sudden change in the slope of the curve. And in this region, we will find the end point or the equivalence point. Okay? Dito mo makikita yung equivalence point. Ibig sabihin, at this portion, tapos na yung reaction. Always sa inflection point. Okay? And also, share ko lang din, at the inflection point, dito mangyayari yung change sa color ng indicator. Dito yan magbabago yung kulay. From colorless to pink, dito nangyayari yun. Okay? So, yan. SKL. Okay. So, let's try to answer this problem. Do the calculations needed to generate the hypothetical titration curve for the titration of 50 ml of 0.05 molar HCl with 0.1 molar sodium hydroxide. Ano gagawin ko dyan, sir? O, ganito. Ano sabi ko nung kanina, pinakaunang sabi ko, alamin mo kung ano yung ginagawa mo. Okay? Alamin mo kung ano yung mga substances mo. Strong acid ba yan? Weak acid or weak base or strong base, no? So, tignan mo yung problem. Ano yung chemicals na meron ako? I have HCl and NaO, sodium hydroxide. So, HCl, strong acid yan. Sodium hydroxide, strong base yan. Okay? So, ibig sabihin yan, strong acid, strong base titration to. Okay? So, ganun gagawin mo. Alamin mo ano yung substances ko. HCl, strong acid yan. NaO, strong base. So, strong acid, strong base titration to. Next question. Sino ang analyte? Sino yung titrant? Okay? Sino ang analyte? Sino ang titrant? Ganito. Si analyte, isang volume lang yung ibibigay sa kanya. And siya yung unang binabanggit parate. Okay? Again, yung analyte, yun yung isang volume lang yung ibibigay at yung unang babanggitin parate. Kasi yung titrant, iba-iba yung volume niyan. Okay? Iba-iba yung volume niya. Okay? So, ito yon. So, ganun ha. And another keyword is this word, no? Magsa-sentence class muna tayo. Yung with, no? Titration with, no? Pag sinabing titration with, followed by this, ibig sabihin ito yung titrant. Okay? Grammar lang. Okay? So, correct grammar or correct intuition, pwede mo malaman kung sino yung analyte, sino yung titrant. Basta nakita mo yung with this, ibig sabihin, with titrant. Okay? So, ganun. So, important yung comprehension sa sentence pag nagta-titration. Kasi baka mamaya mapagbaliktad mo yung analyte titrant, mali sagot mo. Okay? So, mag-ingat. So, we know that HCl is our analyte. So, yan ay strong acid. And sodium hydroxide is our titrant, strong base. SASB ang ginagawa natin. Strong acid, strong base titration. And what are the equations related to SASB titration? Ito. Lahat ng apat na yan. Okay? So, itong apat na equation ang gagamitin mo kapag SASB ang case mo. Okay? So, ayan. So, sige. Alam ko na ano gagawin ko. SASB, alam ko na equations. Ngayon, ang tanong, paano ko po i-execute? Paano ko gagawin yan? No? Okay. So, after mo ma-identify what type of titration you are doing, the second thing you will do is to find the volume of titrant at equivalence point. Okay? So, yun yung next mong gagawin. Hanapin kung nasaan yung volume ng titrant at equivalence point. O, you may ask, paano yun? Okay? Remember, sabi ko kanina, at equivalence point, the mole of titrant is equal to the mole of analyte. Sabi ko yan kanina, di ba? Sabi ko at equivalence point, mole of titrant equals mole of analyte. So from this equation, we can get the volume of titrant at equivalence point. Okay? Yun yung next mong gagawin after identifying ano gagawin mo dapat. Next mo gawin is hanapin mo yung volume of titrant at equivalence point. Mamaya malalaman natin kung bakit. Okay? Hanapin mo muna. Okay? So, since parehas tong liquids, we express the mole of titrant as MTVT and mole of analyte equals MAVA. Okay? So, let's be specific. Ang volume na titrant na hinahanap natin ay equivalence point. So, we write VTEP, si VTEP. No? VTEP tawag namin sa kanya. Okay? So, we rearrange the equation. That's MAVA over MT. Plug in the numbers. MAVA. Yung ML, wag mo na i-convert to liters. Okay lang yan. Kasi magka-cancel out din naman yung molarity. Oops. Okay. 0.1. Divide na yan. Divide. So, 0.05. Although alam ko na sagot, kakalki ko para sure. Okay, so 25. Okay, so alam ko na yung volume of titrant at equivalence point. So what? Alam mo nga, ano gagawin mo? Paano, ano na implication yan? Ganito. Di ba ang daming volume na nilagay? Pinapahanap pH. Ngayon, ang tanong, paano mo kukunin yung pH? Di ba, iba-iba yung stages. And per stages, iba-iba yung equation. So, it is important for you to find first asaan si VTEP, asan yung volume at equivalence point. Kasi, pag nalaman mo na kung nasan yung equivalence point volume, then you can assign the different stages. Okay? Ang purpose, bakit natin hinanap si VTEP, si volume of titrant at equivalence point, ay para malaman kung anong stage yung mga numbers na to. Okay? Kasi pag di mo alam kung asang stage ka, di mo masasagutan to. So we just knew that VTEP, the volume of titrant at equivalence point is 25 ml. So this stage, equivalence point tayo. So ito na yung point of view natin. So anything lower than this is called the pre-equivalence point. And anything higher than this is called the post-equivalence point volumes. Itong 0, edi malamang initial yan. Wala ka pang nilalagay eh. Okay? So, yun yung important. Second na important na bagay. Alamin mo ano yung mga stages. How? By identifying first what is the VTEP. Okay? The volume of titrant at equivalence point. Kasi kung alam mo na kung nasan yung equivalence point, any volumes less than that is the pre-equivalence point. And any volumes greater than this is the post-equivalence point. Ayan, nag-assign na ako ng stages. And since alam ko na yung stages, what's next? Calculate. Pag may question, let me know. Ha? Pero yan. I hope I'm making myself clear. No. So, ganun ha. Diba? Ang tedious, no? Ang dami mong gagawin, no? Pero wala tayong magagawa. No choice tayo. Kaya ganun. Ngiti-ngiti na lang. Okay. So, yan. So, yun yung steps natin. Identify what type of titration you are doing. Identify the VTEP, si volume of titrant at equivalence point. Pag nalaman mo sino yung equivalence point, then you can assign the stages. And since you now know the stages, apply the corresponding equations. Let's solve for the initial pH of the analyte. Okay. So we know that the concentration of acid is just the concentration of the analyte, which is this one. So to solve for the pH, that is negative log of 0.05. May sagot na tayo. Negative log 0.05. The answer is 1.3. 1.30. 1 point. Diba? Sabihin yan, makakasagot na tayo sa finals. Alam na natin mag-solve eh. Ano pa yung kaya sagutan kahit hindi na nag-iisip? Itong equivalence point pH. 7 yan parate for SASB. Okay? So we know H plus is equal to the square root of KW. 2 points na tayo. 2 na lang. Papasa na tayo. Pre-equivalence point. Ano yung question? Ano yung ganap dito? Sabi ko kanina, at pre-equivalence point, the moles of the acid is reduced because we added the titrant. Okay. So to identify how much acid is left, we use the formula N acid minus N base divided by V total. Okay? Para malaman mo gano'ng karami natira, pag subtract mo yung dalawa. What is the acid? Acid is the analyte. So we express this as MaVa. What is the base? That is the titrant. So we express this as MtVt. Then, ano nang gagawin mo? Plug in. Okay? Plug in mo na yung values mo. Okay? Wala nabura. Sige na nga. erase ko na lahat. Okay, so after that, you plug in your numbers kasi you know the equation already. Okay, so MA muna, MA. Ayun, 0.05 times VA, 50 ml, sabi sa problem. Yung units, arbitrary na. Yung ml, wag mo na i-cancel. Okay, minus MT, the molarity of titrant, 0.1 times the volume of titrant, in our case, 10 ml. So, lagay mo 10. Ano yung volume, total volume? The total volume is the sum of the two volumes, the analyte and the titrant added. Okay, so that is 50 plus 10. Okay, using this equation, we can now solve for the concentration of the acid left. And from the concentration of the acid left, you can solve for the pH. Pakipindot ang calcu. And ang sagot natin ay, wait lang, solve muna kayo. Pag may question, let me know para maklarify agad. pH is 1.60. Okay, I hope you arrive with the same answer. Yan. So the pH when we add 10 ml of the titrant is 1.60. Okay, as you can see, it is slightly increased, no? From 1.3 naging 1.60. That means nag-add talaga tayo ng titrant. Then you add certain volume until you reach the endpoint, which has a pH equal to 7. And then lastly, ito, lumagpas na tayo ng 0.1. Post-equivalence na yan. So how will we determine the pH of the solution? By determining how much base is in excess. No, gaano kasobra yung base? Ano formula natin doon? Sir, hindi na po kailangan i-convert to liter. Hindi na po. Okay. Bakit? Kasi ganito. Naalala niyo yung exercise natin ng solution. Molarity times ml equals millimoles. Then if you divide millimoles by ml, you get molarity. Okay. So kaya hindi ko na ipapa-convert, no. Okay? So tingnan nyo. Molarity ml, millimoles 'yan. Molarity ml, millimoles. So millimoles yung numerator. If you divide millimoles by the milliliters, ml, you get the molarity. Okay? So, yun. So, hindi ko na ipapa-convert yung ml to liters. Kasi una, sayang yung oras. No? Okay, so, dire-diretso na. Just take note that m, molarity, times ml is millimole. And if you divide millimoles by ml, you get molarity. Okay. So, conversion is not necessary na. Okay. Okay na yung ml lang. Okay. So, yan. Okay. So, punta na tayo sa post-equivalence point. Again, ano gagawin natin dito? Identify how much acid is in excess. Gano'ng kasobra yung acid mo? So, that is OH minus equal to N base na sobra minus the N acid, no? Yung nagamit, no? Divided by the V total. Base is the titrant, so we write it as MT VT. And acid is the analyte, so we write it as MA VA. And then, what's next? We plug in the numbers. Plug in muna yung molarity, volume, no? So, plug in na natin dito. Ay, sure. A question daw from Kino. Sige. You can use your mic or i-type mo na lang. Sige, okay lang. Sa pre-ep po ba? Molarity pa lang yan. I-convert mo sa pH. Hindi ko na pinakita yung pH conversion, ha. Oo, kasi ina-negative log nyo na lang yan. Type mo, negative log 0.025. Ang lalabas ay 1.6. So, ganun na. Hindi ko na ipapakita yung conversion from H to PH. Okay. Kasi negative log lang yan. Okay. So, master nyo na yan. Okay. Dito, again, suppose equivalence point, OH, meron tayo. So, sobra tayo ng base. So, we can write this as MTBT. Ay, ipa-plug in ko na nga pala. Plug in na natin. Alam na natin equation dyan eh. So, MT 0.1 times, ano na yung volume ng titrant? Sabi sa table, 25.1. Minus molarity ng analyte, 0.05 times 50 ml. Ano napapansin nyo? Bukod sa mahirap. Ano napapansin nyo is, yung volume ng analyte fixed ha. Fixed yan. Kahit anong mangyari, fixed yan. Baka kasi mamaya habang nagka-calculate kayo, dinadagdagan nyo yung analyte nyo. No. Huwag niya babaguhin to Ayan. 50 ml talaga yan. Okay, ang nagbabago lang ay yung volume ng titrant and the volume total. Okay? But the volume of analyte doesn't change. Pag nagbago yon, may mali. Okay? So, ganun. So, yan. Dito tayo sa baba. Volume total sa baba. So, we have 50 from the analyte and 25.1 from the titrant. So, we get the concentration of OH. 0.1 times 25.1 minus 0.05 times 50 ml. 50 plus 25.1. 1.33 times 10 raised to negative 4 molar. So since ano to, OH, ang makukuha natin pag negative log yan ay POH, which is 3.88. Ang gusto ko pH. Edi 14 minus that lang. So I get 10.12. Again, hindi na ako mag-emphasize sa conversions from POH to pH or OH to so on so forth na. Bakit? Kasi that alam na natin siya. Okay. So basta ganun lang ha. OOH yung makukuha mo, convert mo yun sa POH, then since gusto natin ay pH, 14 minus this lang. You will get 10.12. Okay? So yan. So dito pinapakita ko lang yung solving ng concentrations. I-negative log nyo lang yung mga yan. Makukuha mo yung POH pati pH. However, yung POH i-convert nyo sa pH kasi yun yung gusto ko dito. And yan. So we were able to solve for the pH of the solution at different volumes of titrant na dinagdag. No? So if you graph that, so gagawa tayo ng graph. So on the vertical axis, you have your pH. Next slide ko na lang, mas malinis yung slide doon eh. Ayan. So tinype ko na yung answers. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So sa x-axis, lagay ko 5, 10. Again, pag gagawa kayo ng titration curve, on the vertical axis, you have the pH. On the horizontal axis, you have the volume titrant. Okay, sa x-axis ang volume ng titrant. So, i-graph ko yan. Initial, 1.3, somewhere here. 10 ml, 1.6, somewhere here. 25, 7 yun. So, dito yun. Naduduling ako. And then 25.1, andito na siya, 10.12. So if you connect the dots using Excel, so pangit yung magiging outcome ng aking drawing. Pero it will look like that. You have the inflection point, and at this point, you will find the equivalence point or the end point. Okay. So if you graph that in Excel, ganyan ang itsura. Ganyan ginagawa sa lab. no? Kasi wala tayong lab ngayon, kaya sad. Okay, so sad lang tayo. Yan. So that's the titration curve. Exercise tayo. Exercise para mas ma-check ang ating comprehension. Ito, sasagutan ko to na mabilisan. Pero syempre, practice nyo pa rin at home. Okay? So, sasagutan ko to mabilisan para makita nyo kung paano ako mag-solve on my own. No? Para makita nyo kung paano gumagana ang isip natin pag makakita tayong problem na ganito. Okay? So, all you have to do is to watch and to see kung ano yung gagawin ko. Okay? So, kunwari, ilagay nyo yung position nyo sa akin. Kunwari, kayo ay ako. Okay? Kunwari, ako magte-take na ako ng exam. Nakita ko to. Bulaga. Ano gagawin ko? Sasagot na ako ha. Although you can try on your own. So pag nakakita ako ng ganitong problem, una kong gagawin, alamin kung anong types ng acid or base meron ako. Either I have strong or weak kasi. So I have HCl, which is strong acid, NaO, which is strong base. Okay? Ang naunang banggitin, yun yung Analyte. So Analyte, and ito yung Titrant. So I have SASB titration. Okay? So ganun, kailangan within 10 seconds malaman mo ano yung gagawin mo. Okay? Then, after nun, second step, alamin mo si VTEP, the volume of titrant at equivalence point. Okay? So, how do you find VTEP? We assume that the mole of titrant is equal to mole of analyte at equivalence point. Kaya nga equivalence point equal Okay? So, express the moles into molarity times volume. So, MT VTEP equals MA VA. Solve for VTEP. So that's MAVA divided by MT. Plug in the numbers. Okay. So, mabilisan na lang to. Kung gusto nyo i-reviewin, panoorin nyo na lang ulit yung video. Although, sagutan nyo, mas better kung sasagutan nyo on your own. Then, if you arrive with the same answer, then good. Okay. So, MA times 10, 0.05. Sagot ay 20. Okay, so 20 ml. So that means this is my EP. Since I know my EP, I can assign the stages to other volumes. Ang 0, of course, yan yung initial. Ganito ako magsagot dati. Okay, so any volume less than EP is the pre-equivalence. And any volume greater than the EP is the post-EP. Okay? So since I know my stages already, that means I know the equations needed to solve for the pH. For the initial, sabi ko, the concentration of H plus is the concentration of the acid itself. So that is just negative log of 0.1, which is equal to 1. Okay? Okay, so pre-EP, anong equation gagamitin ko dito? H plus equals MAVA minus NTVT over V total. Hopefully, ganito kayo, pag mag-exam na kayo or quiz. Mabilisan. Plug in nyo na lang yung numbers. Okay, again, yung sagot, yun na lang isave nyo, then try to arrive with the answers. MAVA, 10 times 0.1 minus 0.05 times 1 divided by 10 plus 1. Negative log. This is 1.06. Next volume, 10 ml. This is 1.60. Pag na-type nyo na siya sa calcu, palit-palitan nyo na lang yung volume. Okay? Hindi na necessary ulitin lahat. Okay? 19.9, 19.9, 3.78. Ayan. Ilang points na ako? 4 points na agad. Diba? 1 minute halos lang nakalip. 1 minute or 2 minutes. No? Kaya next one, we have the equivalence point. Ano sagot dyan? 7. Pag kayo nagkamali dyan, ako po. 7 yan. Bakit? Kasi H plus is equal to the square root of Kw for strong acid, strong base. And then post EP, the equation to be used here is this. MT minus MAVA divided by the V total. Kasi sobra yung ating titrant na. Okay, so MT 0.05 times MT 0.1 minus 0.1 times 10 plus 20.1. Okay, so this is 10.22. So this is 11.85. And this is 12.1. Okay, so those are the answers. I hope that you will arrive with those answers. No? Okay, madali lang siya. No? Kaya yan in, let's say, 3 minutes. 3 or 4 minutes sa isang item. As long as you know the equation and what to do. Okay? Kailangan alam mo muna kung anong stage ka para alam mo yung equation mo. Okay? And again, be careful. No? Hindi POH ang hinahanap, pH ang gusto. Kaya kapag POH lumabas, subtract nyo yun sa 14. Okay? So I hope na tama yung mga makukuha niyong answer after this class. Okay? So if I draw the titration curve for this one, bakit ko pinapadraw yung titration curve? For you to be familiar. Okay? Kasi mas maganda kung familiar kayo, syempre. So, kasi kapag lab class, pag kunwari face-to-face tayo, magdodraw talaga kayo ng curve by hand. No? Ganon pinapagawa namin. So, initially, 1 yan. At 1 ml, onting akit lang. At 10 ml, that's 1.6. At 19.9, that's 3.78. So somewhere here. 20, that's 7. 20.1, that's 10.22. 25, that is 11.85. Lumagpas. And 30, that's 12. Okay, so yan. If you draw the curve, you will see the distinct shape, the S shape. Diba? Amazing. Okay, so that's the strong acid, strong base titration. Again, we call this region wherein there is a sudden change in the slope that is called the inflection point, and in the inflection point, you will find the end point. Okay, so yan. If you are a BS chemistry student, you will be asked to get the first derivative and the second derivative of the curve. Nagka-calculus kami dito. Nagka-calculus kami dito. Kukunin mo yung first derivative and the second derivative. Okay. So if you draw the first derivative of this curve, it will look like this. You will get the local maxima, 'di ba? Ganun sa calculus, 'di ba, noon senior high nyo. Kung STEM kayo, no, you will get the local maxima when you get the first derivative, 'di ba? Maxima, minima, no, etc. So basta 'yan. Pag ginawa mo yung first derivative niyan, makikita mo yung local maxima, and the local maxima will correspond to the VTEP. Amazing nga na re-relate yung calculus dito sa chem. Okay, so ganun yung idea. So bakit mataas yung niyan? Remember, the first derivative is the slope, no? So yan. Kaya gumaganon dun sa inflection point yan. And anyway, uh, share ko lang yung mga ginagawa sa BS Chem, no? Bilang BS Chem grad, no? So yan, naka-enjoy yan. Hopefully, ma-appreciate nyo yung curves natin and then yung calculation. Sa una lang yan mahirap, pero once you get used to it, no, madali na lang yan. Okay, so yan. Okay, so let's proceed with the next one. If you have any questions, don't hesitate to ask me. Ha? Oh, by the way, di ko papagawa to sa inyo. Yung first derivative, second derivative. No? Yung curve lang. Okay. Mas ma-appreciate nyo, uy, andito yung andito yung endpoint. Andito yung equivalence point. Okay. Baka po isali. Ay, hindi. Hindi siya isasali. Pang BS Chem na talaga yan eh. Kaya hindi na yun, hindi. Ito lang, yung curve lang. Ang gusto ko lang maging familiar kayo is sa curve. Kasi kunwari binigyan ko kayo ng curve, paalamin ko sa inyo ano components neto, strong acid, strong base, weak acid, weak base. Okay lang, alam niyo sagot doon. Okay? Kasi from the curve, malalaman mo kung ano yung components ng iyong substance. Yun yung reason bakit may curve drawing ako sa gilid. Okay? So yan. So from this curve, you will see kung ano yung mo, kung ano yung kung ano yung components mo. Pag strong acid, strong base, smooth lang yan. And you have one inflection point. Okay? Huwag kayong mag-worry sa first derivative. Wala kayong calculus data, di ba? Kaya lang ganun. Chill lang. Okay, so yan. Let's proceed with the next one. Yung strong acid, strong base, pag binaliktad mo, you will get strong base, strong acid. Diba? Amazing. Kunwari, yung aking titrant kanina ay base, ngayon ang titrant ko ay yung acid. Yung analyte ko kanina ay acid, ngayon ang analyte ko ay base. Okay? So, we will have Sbsa titration. Okay? So, yan. Take note that the roles are reversed. No? Strong base now is our analyte and strong acid now is our titrant. Okay? So, the equations will be in reverse. Babaliktad. Okay? Okay, so ganun lang. 'Di ba kanina acid yung analyte, titrant yung base. Baliktad ngayon. So as a result, baliktad din yung equation natin. Okay? So, pero same concept pa rin, no? So, for example, initial, you have the base only. To get the pH of the solution, kunin mo muna yung concentration ng hydroxide. Directly yung makukuha kasi strong base to. O kung ano yung concentration ng strong base, yun na yung concentration ng hydroxide. I-negative log mo yun, makukuha mo yung POH. Then, minus mo yun sa 14, you will get the pH. Dapat alam nyo na yan, na. So, from POH, gagawin mong pH. Next one. Sa pre-equivalence point, I will be adding strong acid titrant. So, ibig sabihin nun, mababawasan yung base ko. To determine how much base ang natira, ilang base na lang yung natitira kasi nadadagdagan tayo ng analyte, nadadagdagan tayo ng titrant. So, to solve for the concentration of the base remaining, we use this formula. N base minus N acid divided by V total. Okay? Mas marami pa rin yung base kaysa sa acid. Okay? Kaya ganito yung formula, base minus acid. Okay? So the base is the analyte, so MAVA. The acid is the titrant, MTVT. Okay? Divided by the volume total. And as you can see, similar yung concept, baliktad nga lang yung roles. No? Dito, OH yung sobra sa pre-equivalence. No? Kaya ganito yung formula. Take note, baka isipin nyo, sir, kanina, itong equation, MTBT minus MABA. Hindi, no? Kasi, in our case, yung ating base, yun ay analyte. Kaya MABA pa rin. Yung ating acid, yun yung titrant, kaya MTBT. Okay? Nagbaliktad ng roles, no? Pero as you can see, the equation is similar, no? Kaya yan. And at equivalence point, yung acid and base, mawawala sila. They will be neutral salts. For example, NaO plus HCl again. At equivalence point, they will all be converted to HCl and water. Wala na yan. So the pH is contributed by the water na lang, the self-ionization of water. So basically, that's 7 pa rin. So pH is equal to 7 here at 25 degrees Celsius. And at post-equivalence point, ano yung sobra? Yung titrant. Ano yung titrant? Acid. No? So if you want to determine how much excess acid ang meron, you use this formula. N acid minus N base divided by V total. Remember that your acid is the titrant. So MT, VT. And your base is the analyte. So MAVA. Okay? Okay, yan ha. Take note, baliktad yung situation natin. Kanina, yung base, yung titrant. Ngayon, yung base, yung analyte. Okay? Baka isipin nyo, hala sir, baka nagkamali ka ng copy-paste. Hindi. Ganun talaga. Okay? Reversed ang role natin. Okay? Ayan na, take note nyo na lang. And again, sabi ko nga sa inyo, pwede nyo naman balik-balikan yung slides. No? Okay? Kunwari, ay, nakalimutan ako formula. Balik kayo, okay lang. Wala namang pipigil sa inyo bumalik sa slide na to. Okay. So, since the roles are reversed, the curve is also reversed. Still, pero yung processes ay makikita mo pa rin. No? Yung mga steps, makikita mo pa rin dito. So, you have the initial on the and on the higher pH, syempre basic, no? Higher pH, the more basic, no? Lower pH, the more acidic. So, the titration curve for Sbsa is baliktad. You start with the high pH and then slowly it will decrease until you reach the inflection point. No? Inflection point. And once you are in the inflection point, that means you are in the equivalence point or the end point. Dito na magbabago yung color ng indicator. Okay? Then, kapag lumagpas, you will have post-equivalence point. Ibig sabihin, puro acid na lang yung sobra. And again, remember, ito yung equations na gagamitin. Okay? So, mapapansin nyo, dalawang subtopics pa lang tayo, strong acid, strong base, no? Tapos, each topic may 4 na equation. May 2 pa tayong didiscuss. Kaya nga ginawa ko, nilista ko na yung equation para sundan nyo na lang, okay? Ang gusto ko lang na ma-develop is, number 1, identify. Ano yung gagamitin ko sa 16 na equation? Okay, 16 yung overall equation eh. Kasi may 4 na equation for the 4 subtopics. Strong acid, strong base, strong acid, weak acid, strong base, weak base, strong acid. So 14 yon, 4 times 4 eh. So gusto ko ma-develop nyo. Alamin yung paano nyo malalaman alin sa 14 equations yung gagamitin ko. Okay. Alin sa 16 equations yung gagamitin ko. Okay. So paano nyo malalaman yon? Identify the molecules present in your solution. Okay. So ganun na. Identify the molecules and identify kung sino yung analyte, sino yung titrant. Okay. So ganun lang. Basta marunong kayo mag-identify, you will not have any problems na. Okay. Ang poproblemahin nyo na lang ay yung calculator. Okay. So let's try this one. Calculate the pH during the titration of 50 ml of 0.05 molar sodium hydroxide with 0.1 molar HCl at 25 degrees Celsius after the addition of the following reagents. Okay. Ano yung sabi ko sa inyo? First thing na gagawin nyo after basahin ng problem ay, bukod sa magdasal, alamin ang compounds. I have sodium hydroxide, I have HCl. Sodium hydroxide is a strong base, HCl is a strong acid. Ano pa yung tip ko kanina? Kung sino yung unang sinabi, siya yung analyte. Ito yung unang sinabi. Ibig sabihin, siya yung analyte. So, yan ay Sbsa titration. Okay? Kasi kapag baliktad yan, SASB, edi yung kabilang slide gagamitin mo, yung dinaanan na natin. Okay? Ano pa yung isa pang keyword? Sabi ko, grammar. Titration with, ibig sabihin nun, after ng with, ang sasabihin ay yung pangalan ng titrant. Okay? Pag nakita nyo yung with, ibig sabihin, titrant kasunod nun. Okay? Based on grammar, no? Okay. So, ganun lang, ha? Reading comprehension is a must, no? Pero binigyan ko na kayo ng clues. Kung sino yung unang sinabi, siya yung analyte. Or, pag nakita nyo yung keyword na with, ibig sabihin, kasunod nun ay titrant. Okay? So, yan. So, SB is our analyte. SA is our titrant. So, the equations to be used ay yung SB-SA equations. Ito yon. Yan. Okay? Next gagawin after, alam ko na yung gagawin ko, SBSA to. I know the 4 equations already. Hanapin si VTEP, no? Ang ating friend na si VTEP. So, saan tayo ulit mag-start kay VTEP? N titrant equals N analyte. Bakit ko inuulit-ulit to? Ba't di na lang ibigay yung formula? Para masanay. Okay? Kasi malay mo, may revision sa formula. Okay? May mangyaring wonderful sa formula. Okay. So anyway, so according to John Gabriel, VTEP is 25. Okay. So since VTEP is 25, thank you, John Gabriel. Okay. So since VTEP is 25 ml, so that means 25 ml is our equivalence point. Okay. Plug in lang yan, ha. Okay. So yan. Hindi ko na papakita. Mabilisan na lang tayo kasi baliktad lang yung process eh. Okay. Baliktad lang naman yung process. So this is pre-equivalence point and this is post-equivalence point. Okay. And then you can now apply the corresponding equations. Sa VTEP, ang pH ay 7. Huwag nyo na isipin masyado kasi 7 talaga yon. Okay. Ang equation doon ay H plus equals square root of KW. Pre-equivalence pH, ano yung sobra dito? Yung base. Sobra yung analyte natin. So, calculate the base. So, ano gamit natin formula doon? MAVA minus MT over V total. Okay? Ano susunod? Plug in. Plug in, plug in. Basta alam mo formula na gagamitin mo, tuloy-tuloy na yan. MA 50 times 0.05 minus MT 0.1 times 24.5 divided by total volume. Ipag-add mo lang yung sa analyte and sa titrant. Ano yung pH? Hindi ko na kaya i-mental yan. 14 minus negative log. Sagot ay 10.83. Hopefully nakuha. Okay? So, yan. Hala, sir. Baka sabihin nyo, hala, sir, ang nakuha ko ay 3.17. POH yun. No? Kasi OH to eh. Okay. So, kung gusto mo yung pH, 14 minus the POH. Okay? So, ganun. Post-equivalence point. Ano yung sobra dito? Titrant. Ang titrant ay acid. So, ibig sabihin sobra tayo ng acid. Alamin mo kung gaano kasobra yung acid. What's the formula? MT VT minus MA VA over V total. Okay? Basta alam mo kung sino yung sobra. May idea ka na sa equation na gagamitin. Okay? Pag na-master nyo talaga to, feeling ko, pwede na kayo pumasa sa Chemical Technician Board Exam. Ganito lang din daw kasi yung sa Chemtech Board Exam eh. Ang level kasi, ang antas sa field ng chemistry, kami yung mataas, chemist, kasi 5 subjects kami. 5 subjects, 100 items yung board. Tapos sumunod is the Chemtech. Ito yung mga tumutulong sa analysis. No? Although kami yung taga-pirma. Okay. Chemtech sila yung mag-a-assist sa'yo. So, alam ko 3 subjects lang yan, 100 items. Anong subjects meron doon? Anachem, OrgChem, InOrgChem. Meron na kayo ng 3 subjects na yon. Kaya kung gusto nyo mag-Chemtech, pwede din. Designed yon para sa hindi Chem majors. Para 2 license nyo. Okay. Ang problema, 2 din yung CPD points nyo. Maubos na kayo ng pera kaka-seminar. The more kasi na marami kang expertise, the more na mas malaki yung the more yung chances mo magkaroon ng maraming trabaho. Okay. Yan. Okay, so that is the equation to solve for the excess acid. Now, since we are at the post-equivalence point. So 25.5 minus 50 times 0.05, 50 plus 25.5, the answer is 3.18. Yan, okay? So good, nasusundan na natin. Ano kaya itsura ng titration curve neto? So strong base, strong acid yan. So basically pag ganun. Okay? So pag ganun lang yung curve niya. Pangit kasi. Pangit talaga yung drawing ko dyan. Okay? Pero 3 points lang kasi meron tayo. The more points you have, the better the curve will be. Okay? So ganun. Siguro, for you to appreciate this more, maybe I will open a Google form, na pwede nyo pag-practicean yung mag-upload na lang ako siguro ng Excel. Pag-practicean nyo yung yung curve. Although hindi ko siya isasama sa quiz kasi multiple choice naman yung quiz natin. Pero lang, better kasi kung skilled kayo sa Excel. No. Malaking tulong yung Excel pag nagtrabaho kayo Okay. So, yan. Ayan. So, these are the answers. Okay. So, yan. I hope na nakukuha. No? If you have any questions, don't hesitate to ask me. Because again, crucial itong topic na to. If you cannot answer the basic questions, then you will find the other questions very hard. No? Kaya yun. So, kailangan basics ay alam. No? Ayan. Kaya, tinagalan ko tong session natin ngayon. Okay, so for you to be more familiar or more exposed sa titration problem, I want you to answer this slide, no? This is slide number 19, page 19 sa PDF. So I want you to answer this. Isasama na natin to sa worksheet nyo para mapag-practicean nyo yung calculations and yung drawing ng curves. Okay? So I will end the session here muna. Okay? Pero may mga pointers akong sasabihin after this na. So stay put muna kayo. Kung gusto niyo kumain, kain muna kayo. Okay. So tapos na muna yung ating discussion today. Pero magbibigay ako ng pointers for the other sessions natin. So what are those pointers? Ganito. Insight na lang to para next meeting mas mabilis yung ating discussion. Kasi paulit-ulit lang to Yung 16 na equation, ulit-ulit lang yan Okay. So yan. So you are now familiar with the strong acid and the strong base, no? Ngayon, punta na tayo sa weak acid, weak base na. Although overview lang ibibigay ko Hindi ako magfo-full discussion kasi gutom na kayo. Ako rin nagugutom, okay? So ni-restart ko, ayaw mag-full screen Okay. So yan. Ayan, full screen na siya. Okay, so ayan. So again, compare natin. SA, smooth yung curve, no? Smooth siya. SB, smooth din, baliktad nga lang. Okay? Pero kapag may weak acid ka or may weak base, may something distinct sa curve mo. Okay? So kapag strong acid, strong base or vice versa, smooth yung curve, no? Nakikita mo dire-diretso lang siya. Okay? Beautiful yung curve niya. Pero kapag may weak acid ka or may weak base, there is something unique with the curve. May bump, okay? May bump siya, may bukol siya dito. Parang nauntog siya slight. Bakit? The bump in the titration curve tells us that there is a buffer region. Okay? Siguro magtataka kayo, bakit may buffer doon, sir? Ano na naman yan? Okay, ganito kasi. Remember that this is a weak acid. Weak acid tayo, ha? When you neutralize portions of your weak acid, they convert into conjugate base. And ano tawag natin? If we have a system with an acid and a conjugate base, tawag natin doon ay buffer solution. That's why may bump dito because of the presence of the conjugate base and the weak acid. Okay? So, buffer region to. So, compare mo yan sa strong acid, strong base. Ang strong acid, strong base, smooth. Okay? Smooth lang siya. Pero kapag yan ay weak acid, weak base, may bump na. May bump na. Ano mapapansin natin dito sa portion na to? As you can see in this portion, the pH change is negligible. Masyadong maliit yung pH change. Although, ang laki ng volume changes. No? So, starting from this region to this region, ang laki ng volume change but the pH change is maliit lang. Okay? Kasi, buffer yon. Ano sabi natin last time sa buffer? Buffer is a solution that resists pH change. No? Kaya ganun. Okay, dagdag ka ng dagdag titrant pero onti lang nagbabago sa pH. Buffer kasi yon. And then after the buffer, you have your beautiful inflection curve wherein the equivalence point can be found. Okay, so dito na magkakaroon ng endpoint. And after that, back to normal. Kasi puro bases na lang dito. Excess na yung base dito. So, yun lang gusto ko ma-appreciate nyo for now para next meeting tuloy-tuloy tayo. May bukol siya because of the buffer region. Malaki yung change sa volume but the pH change is maliit. Okay. And given that, ito yung ating mga equation. We will use the Henderson Hasselbach equation. Okay. And si HHE, Henderson Hasselbach equation. Ito, square root of tsaka. Familiar, di ba? Pag tinignan nyo yung discussion sa Khan Academy kay or organic chemistry tutor, kasi nanonood din ako noon minsan to improve my approach sa topic, no? Siyempre bilang teacher, kailangan alam mo kung paano yung mga effective ways to discuss the lesson, no? Kaya lahat ng simplification gagawin ko talaga. So tinitignan ko doon, mas correct yung equilibrium. However, the approximations can be used, no? Small x approximation yung ginamit ko, and that's the reason why I arrived with these equations. Kasi ito nga, ginagamit namin tong equation sa board exam. So this must hold true for most of the problems. Okay? So yan. So ito yung bumuhay sa akin ng boards. No? Kinabasado ko yan? Hindi. Ang inalam ko lang ay ito. Tapos saka na ako gagawa ng equations. Okay? So ganun. And yan, nag-answer din ako ng ilang items. Ito question, then suddenly may answer dito sa next page. So I want you to practice on those items para pag diniscuss ko, gets agad na. Then magsasagot ulit tayo ng isa pang item. I-curve ulit natin yan. Then we have the weak base strong acid titration naman. Compare that with the strong base strong acid. Ito yung strong base strong acid. Smooth yung curve. Di ba? Makinis yung curve niya. However, ano mapapansin nyo kapag weak base strong acid, may bump, may bukol uli, no? So there is a region where there is a little change in the pH. However, the volume change is very big, no? And we call this region the buffer region. Bakit may buffer region uli dito, sir? Because of the presence of the base and the conjugate acid. And this region is governed by the Henderson-Hasselbach equation. Okay. So, malaki yung volume change, the pH change is not big. Buffer yon. So after the buffer, you have the beautiful inflection point or the inflection curve where the equivalence point can be found. And then after that, excess acid na yung sobra. Kaya smooth na lang siya uli. Okay? So ano yung idea dito? Kapag weak acid, weak base, mayroong bump, no? May region wherein the change of the pH is not so big, no? Kaya very noticeable siya sa graph. Okay? Hindi agad nagbabago yung y-axis. That's called the buffer region. And these are the equations necessary to carry out the pH calculation. All of this ay small x approximation, ito in square root of CBKB. This is the Henderson Hasselbach in the base form. Okay, and so on and so forth. Now, I will discuss this in depth next meeting. Pero mas maganda na yung familiar na kayo dapat. You may want to try those equations in this problem kasi given na yung sagot. Okay? Pero syempre, di-discuss ko pa rin yan. Okay? And ito, try din natin yan. Just in case lang marami kayong time, ha? Pero I don't know if marami kayong time, no? Mga pillars of strength natin. So, yan. So, ito yung ating isang activity then next meeting. We will try to draw the curve for this one. Okay? Hopefully, maganda yung curve na magawa natin. The next meeting, discuss natin indicators, paano nagiging colorful sila, and what are the implications of the concentration with the colors. And we will have the polyprotic acid-base titration. By the way, if you check this part, nakakaiyak siya. Okay. For example, diprotic acid, ganito karami equations. Triprotic acid, ganito karami equations. Bulaga, di ba? Ito, diprotic base, ganyan karami equation. Nakakaiyak, di ba? Kaya ang gagawin lang natin dito is dadaanan lang natin sila. Okay? So, yan. Sa worksheet, ako magbibigay ng sample problem, although may answer na yan, syempre. Okay? So, yan. So, bakit naging ganyan yung equations? Because of the presence of the buffers. No? May buffer dito, kaya ganyan. May buffer dito, kaya ganon. Okay? And then, mapapansin nyo, you have two inflection points. You have two inflection points. This one and that one. Okay? Ibig sabihin, diprotic yan. Pag tatlo yung inflection point, ibig sabihin, triprotic yan. 1, 2, 3. Okay? So, yan. Although more details will be discussed next meeting, ha? Okay, so you can study in advance kasi may mga items na ako na sinagutan. Okay, so for you to be guided. Okay, so I think that's enough, no? Kasi gutom na rin talaga ako. So, I hope na kumakain na kayo by this time. And with that, we will end our session. We will resume next meeting, which is Friday. And resume tayo next meeting with the weak acid strong base, the weak base strong acid, and the polyprotic acid-base titration and the acid-base titration indicators. Okay. So, do you have any questions about our session for today? Any questions or okay na tayo? I think okay naman tayo, no? Okay. So, I hope na nasundan, no? I hope na nasundan kasi pag hindi, mahirapan talaga tayo. Kaya please ask the questions bago pa man mahirapan sa dulo, okay? So yan, if gets naman, then that's good. That's very good, no? And ako na nagsasabi sa inyo, pag gets niyo talaga tong titration, pwede na kayo mag Chemtech board exam para dalawa license nyo bukod sa RMT. Diba? Okay. So with that, I would like to thank you for your attendance and I'll see you again next meeting. Again, stay safe. COVID cases are still surging because of the presence of the recent variant, Philippine strain. So mag-ingat parate. So I'll see you again next meeting. Bye-bye and stay safe. A copy of the recording will be uploaded on YouTube. Bye-bye.